Hi, welcome back. This is Rakesh Naik. Today we are going to see some more examples on minimization of states. But before we start, small information I'd like to share. In this channel we produce every video in two different languages, Hindi as well as in English. And if you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. We have already seen how to minimize the steps in a DFA. If you have not seen that video, kindly follow the link given in the I button. This is the problem given. A DFA is given and correspondingly its transition table is given. And the first step, we understand that we need to remove all the unreachable states from the starting state. So in this DFA, we don't find any such state which is not reachable. From Q0, I can go to Q1, then Q3, then Q4, then Q2. I can reach to each and every state. So step 1 of removal, all the non-reachable states are not required. The next step is construction of pi naught. In pi naught, if you remember what we do, we make the subset of all the states which are final states and all the states one more subset having non-final states. Here Q4 is the only final state. In one partition I'll take Q4 which is the final state, and in another partition I'll take Q0, Q1, Q2 and Q3 which are the non-final states. So based on this pi naught value, I have to calculate pi 1. As in the first partition, Q4 is the only one state available, so I cannot subdivide it anymore. So I have to take the other partition. In other partition, let us take any two states, let it be Q0 and Q1. So concentrate on the rows which contain Q0 and Q1. You can see the transition. Q0 on 0 is Q1, Q1 on 0 is Q1. So Q1 is lying in this particular partition. Similarly, Q0 on 1 is Q2 and Q1 on 1 is Q3. Q2 and Q3 are also lying in this particular partition. So I can say Q0 and Q1 are one equivalent. Let us take one more pair. Let it be Q1 and Q2. Q1 and Q2 belongs to this partition, and let us concentrate on these two rows only. So Q1 on 0 is Q1, Q2 on 0 is also Q1. Q1 belongs to this partition, same partition. Similarly, Q1 on 1 is Q3 and Q2 on 1 is Q2. So Q2 and Q3 belongs to this partition. So I can say Q1 and Q2 are also one equivalent. As we have already seen, Q0 and Q1 are one equivalent, and we got Q1 and Q2 are one equivalent. We can say Q0, Q1, Q2 are one equivalent. Let us see whether Q3 are equivalent to this or it is separate. So I have to check Q2 and Q3. So concentrate on these rows only. Q2 on 0 is Q1, Q3 on 0 is Q1. Q1 and Q1 belongs to this partition. Q2 on 1 is Q2, Q3 on 1 is Q4. Now you can see Q2 belongs to this partition, but Q4 belongs to a different partition. So I cannot say that Q2 and Q3 are one equivalent. Rather, I'll say Q2 and Q3 are not one equivalent. So those which are one equivalent, I'll make a separate partition, and those which are not one equivalent, I'll make them as a different partition. Now, based on the value of pi naught, we got pi 1. And pi 1 having three partitions now. One partition contains Q4, another partition contains Q0, Q1 and Q2, and one more partition contains Q3. So here Q3 and Q4 are single states. I cannot subdivide it anymore. So I'll concentrate on this partition where three states are defined. I'll take two states from this partition. Let it be Q0 and Q1. So I'll concentrate on these two rows only. Q0 on 0 is Q1, Q1 on 1 is Q1. And Q1 and Q1 belongs to this partition. Similarly, let us check Q0 on 1 is Q2 and Q1 on 1, it is going to Q3. You can see Q2 is here in this partition, but Q3 is in a different partition. So I cannot say that Q0 and Q1 are two equivalent. Rather, I'll say they are not equivalent. So one more pair we'll see, Q1 and Q2. So let us concentrate on these two rows. So Q1 on 0 is Q1, Q2 on 0 is Q1. So Q1 and Q1 belongs to this partition. Q1 on 1 is Q3 and Q2 on 1 is Q2. So Q2 is in this partition, Q3 is in this partition. So I can say that Q1 and Q2 are not two equivalent. So what we got? Q0 and Q1 are not two equivalent and Q1 and Q2 are not two equivalent. So we'll take two states from this partition. Let us take Q0 and Q2. So let us concentrate on these two rows only. Q0 on 0 is Q1, Q2 on 0 is Q1. So Q1 and Q1 belongs to this partition. So they are in the same set. Q0 on 1 is Q2 and Q2 on 1 is Q2. Q2 and Q2 belongs to this partition also. So I can say Q0 and Q2 are two equivalent. From this I can take Q0 and Q2 as one partition and Q1 as other partition. Now you can see Q4 is a separate partition, Q0, Q2 is a separate partition, Q1 is a separate partition and Q3 is a separate partition. Now let us check Q0 and Q2 are three equivalent or not. Now let us check Q0 and Q2 are three equivalent or not. So you need to take Q0 and Q2 and concentrate on these rows. Q0 on 0 is Q1, Q2 on 0 is Q1. Both of them belongs to this particular partition. So no problem. Then Q0 on 1 is Q2 and Q2 on 1 is Q2. So Q2 belongs to this partition. So there is no problem. You can say Q0 and Q2 are three equivalent. So you got another pi, that is pi 3, that is same as pi 2. So you reached at a condition where pi 2 equal to pi 3. So we'll stop here and we'll go to the next step, that is writing of our DFA. So whatever partition we got, these are called equivalent classes. And these partitions will become my states for my minimized automata. One more easy way of writing is wherever Q0 is appearing, write the full partition Q0, Q2. So instead of Q0, I'll write Q0, Q2. Instead of Q2, I'll write Q0, Q2. Q3 is a separate partition, so I need not write anything for this. Q1 is a separate partition, so I did not write like this. And you got this table. And from this table, any repetitions are there, I'll write it in the form of this one. Now, in the original table, Q0 used to be my initial state. So, in whichever partition Q0 is appearing, that will be my initial state. Similarly, Q4 used to be my final state in the original one. And Q4 belongs to this partition. So this state will be my final state. Now, let us try to draw the DFA required for it. So the DFA required will be this. So this is the required minimized automata that we got. I hope you understood it. Let us do one more problem very quickly. So this is a DFA given, and based on this DFA we want to see the minimized state. The first step is to remove all the unreachable states. Now you can see Q3 I cannot reach anyhow. So I'll remove Q3 state and the diagram that I'll get is this one. And based on this one, again I want to minimize it. Here there are two final state and one initial state is there. So based on these final state, I'll be constructing my pi naught. So for pi naught, there are Q1 and Q2 are the final state in one partition and Q0 is a non-final state in another partition. So based on this result, I'll construct pi 1. So you can see Q1 on 0 is Q2 and Q2 on 0 is Q1. So Q1 and Q2 belongs to this partition. Similarly, Q1 on 1 is Q1 and Q2 on 1 is Q2. Belongs to the same partition. So I cannot partition it anymore. So I can say Q1 and Q2 are equivalent also. So based on these equivalent classes, I have drawn these states. And Q0 used to be the initial state and Q0 belongs to this partition. So I'll say this is my initial state and Q1 and Q2 are my final partitions, and in whichever states Q1, Q2 appear, that will become my final state. So based on this transition table, I'll draw my transition diagram, and this is my minimized automata. I hope after doing these two problems, you understood how to minimize states by partitioning method. If you understood, give me a like and share among your friends. In our next video, we are going to learn minimization of state by one more method. So see you then, take care, bye.